Hello and welcome to Beginning Yii. Before we launch into discovering Yii, I'd like to introduce myself and take a quick peek at how we'll explore and become familiar with Yii during this course. My name is Chris Backhouse. I'm a freelance web developer living and working in France. I have 25 years of IT experience, including 15 years of object-oriented development and relational databases. Much of my IT career was spent in customer-facing roles, such as project management and business analysis. And this has taught me to develop customer-centric applications, and I'll talk more about this later. I've been using web technologies for over 10 years, starting back in 1995-96 when developing a project for Microsoft UK. And about 3 years ago, I decided to make the transition from Microsoft-based technologies to LAMP technologies. And when I first started with PHP, I very quickly understood the need for a framework and started developing with Yii. For the past 2 years, I've exclusively used Yii and have been developing complex Ajax-based web applications. During this course, we're going to develop a fully functional application in Yii. But before we start developing, we'll look at some of the theory behind frameworks. What are the advantages of frameworks? And what are MVCs? And what is the flow in a normal web request? For this course, you'll need a basic LAMP or WAMP setup. And we'll look at both the prerequisites and the ideal development tools. And then in section 2, we'll jump straight in and set up a new Yii installation and create our first web application, all in one chapter. Yii encourages a test-driven, iterative development approach by close integration with PHPUnit and Selenium server. And that means that we'll be able to create our test scenarios alongside our main development and test our application as we go. We'll look at different ways that Yii queries databases through the ActiveRecord data object, building SQL queries using the command object, and running SQL directly. We'll also look at when we should use which one. Yii has theming support, and we'll install a pre-built theme and then learn how to customize it. By the end of the course, you'll have a thorough understanding of developing in the Yii framework, and you'll have built a fully functional web application. Hello! In this session we'll explore the definition of a framework and why they're beneficial to web application developers. In a traditional bare-bones PHP development environment, a developer is required to create interfaces for each aspect of the system, e.g. database access or user authentication, and a framework is one kind of solution to this problem. In information technology terms, and particularly web development terms, this could be defined as an abstraction in which software providing generic functionality can be selectively changed by user code, thus providing application-specific software. And one of the holy grails of software development is reuse. And reuse enables efficiencies in the amount of new code required, thus time and cost, not just in pure coding effort, but all the other tasks undertaken as part of the development lifecycle, design, coding, testing, etc. In the past, in pursuit of this holy grail, we've seen the creation of toolkits and libraries. A library can be defined as a collection of routines bundled together to provide functionality for a specific domain or area. And with a library, the application developer decides when and how to call a library function. There is no constraint other than syntax, how or when the application developer decides to incorporate that library. A framework, on the other hand, provides a developer with an application skeleton into which the developer can drop their code, and one could suggest that this application framework is a blank application waiting for the developer to fill in, a bit like an MS Word template. But what particularly distinguishes a framework from a toolbox or library is something called inversion of control, and this means where the framework can take control of the order of processing, for example with a callback. We'll be familiar with this concept in a Windows GUI development language, such as JavaScript or C#, etc., where we add code to events, such as onClick or onChange, and the user, and/or Windows, decides when these events are executed, not the programmer. And this is a fundamental difference between a library and a framework. Another key feature of a framework is extensibility, the ability to override or extend a base class using inheritance, and add or replace features to provide new functionality. For example, we might want to override the user identity class to change the way that user authentication is handled. Lastly, from a developer's perspective, frameworks can free us up to concentrate on developing the business functionality required by the client. Now back to reuse, the holy grail of all software development, and let's look at some statistics. Some sources claim that object-oriented programming can offer cost savings over procedural programming of between 20 and 60%, and frameworks can make up the difference and add another 20 or 30% cost saving. When you add these two together, that can be a massive saving of between 40 and 90%. So in this session, we've looked at what a framework is, and we've discovered the defining term inversion of control. We've seen that frameworks can remove the need to code repetitive complex functions, and we've seen that the advantages of using a framework can save the developer a lot of time and effort. In this session, we're going to explore the MVC architecture pattern and what it is and why we use it. Many frameworks, including Yii, are based on the MVC architecture pattern. And this architecture separates the different aspects of an application into the relevant components. The model, view, and controller architecture is based on isolating business rules, presentation, and control logic into separate components. The primary reason for this is to produce a more structured, easily maintainable code and thus to promote reuse. Yii stores the classes for each of the model, view, and controllers in a directory. For each controller, there is a PHP file representing that controller. Similarly, for the models. For the views, there is a subdirectory, one subdirectory for each model class, and within that, PHP file for each of the views defined for that model. Looking in more detail at each of these elements, the model holds the underlying data structure of the application and contains the business logic for maintaining the integrity of that data. Business logic normally refers to such things as data validation and shouldn't be confused with application logic. The model may also contain code for manipulating data, for example, with a search function or populating lists and resolving relational dependencies. Within Yii, the model is represented by the base class C model, which is extended by two higher classes, Yii ActiveRecord and Yii Form model. The ActiveRecord class represents database access in an object-oriented fashion. A new instance of the AR object is created for each record read from the database. Table columns, or fields, from the database are represented by public attributes of the model in the form $model attribute. Basic SQL tasks and queries are handled easily by the AR class. For example, to create a new record in a blog post might be as simple as the following example. The view is responsible for rendering the output to the user, so is normally a mix of PHP and HTML. Yii has a number of helper classes for creating HTML, such as URL creation, images creation, and form elements. Yii also has a large and powerful collection of inbuilt widgets, many of which are closely tied in with jQuery UI widgets. This removes many of the complexities of building complex web forms. The controller is both the glue and the router between the data model and the view. All requests are routed through the controller in the form of actions. Actions are entry points to each operation required by our application and will call models and render views as appropriate. Controllers are responsible with dealing with end-user requests, such as $get and $post variables. In conclusion, we've seen how MVC architecture is designed to produce more structured and maintainable code, and the roles that each component of this architecture takes within the application. In the next section, we'll look at how these three components communicate and the flow of information in a typical web request. Hello. In this session, we're going to trace the request routing of a typical web page to better understand which part of the application is responsible for what. In the last session, we discussed how the different MVC components relate to each other and their associated tasks. And before we look in more detail at the information flow, there are a couple of more elements that I need to introduce you to. Like many frameworks and CMS applications, Yii uses an index.php bootstrap file through which all traffic is funneled. The index.php bootstrap is only responsible for running the Yii application. The Yii application component is the front-end controller and decides how to route the application request. The routing rules used by the application component are configurable in the web application's config file. The default URL format is http hostname/index.php r=controller-id/action ID. However, for the rest of this course, we're going to use a more SEO-friendly format and thus configure the routing to accept URLs in the format hostname/controller-id/action ID. The application component will parse the incoming URL and decide to which controller the request is sent. Let's take the classic CMS blog application as an example and follow the routing through a single request. We're browsing a list of blog entries and we click on a blog entry to pull up a screen to update that blog article. So looking at the flow of information in more detail, the URL sent by the click is something like this: hostname/post, which is the controller ID, /update, which is the action, ID = 7. The index.php file is loaded, and this calls the Yii application component router. The router calls a component called request to obtain detailed information about the user's request. The application router then calls the URL manager to determine the controller ID and the action ID requested from the URL. The post controller is loaded in this example, and the function actionUpdate is called with the parameter ID = 7. The post controller creates an ActiveRecord class for a post model and calls the ActiveRecord findByPrimaryKey method. The AR instance accesses the database and loads the record with a primary key of 7. The controller retrieves the populated AR instance, and then it calls the update view, passing the AR model instance with it. The update view renders the HTML using data from the AR model instance and outputs completed HTML back to the user. In our last session, we discussed one of the advantages of an MVC is the separation of code, and we can see from this diagram that it would be very easy to have the controller call one of two views depending on some criteria. For example, if the user were using a mobile browser, we could render a different view. In summary, we've seen that the controller controls the flow of information between the model and then the view. We've also demonstrated one of the advantages of MVC is the separation of code, illustrating how we could easily add another view to be called depending on the browser being used. Hello, we've talked about frameworks and MVCs in general, and in this, the last theory session before we get hands-on with Yii, we're going to discuss what makes the Yii framework stand out from other frameworks. Yii was launched in December 2008, and its founder, Qiang Zhu, had previously worked on the Prado framework. Feedback and experience gained on the Prado project led Qiang to understand the need for a fast, secure, and professional PHP 5 framework. Yii's extremely impressive performance metrics, when compared with other PHP 5 frameworks, quickly drew wide attention. So what are the features that make Yii so powerful? It's efficient. We've already discussed the advantages of the MVC architecture, which encourages a reusable or dry, don't repeat yourself development approach. It's fast. Yii has been built from the ground up with performance optimization in mind, and it's now one of the most efficient frameworks around. It has inbuilt support for database caching. Yii uses a single cache class that is then extended by specific caching methods, such as AppCache and XCache. Yii has a built-in templated code generation system called Yii, which will generate all the files required for an MVC CRUD system for each database entity. The code generation will use foreign keys to build relations within the data model, and using the InnoDB database engine with MySQL enables Yii to interrogate the database and define relations between data models based on the defined foreign keys in the database. Yii can also be extended using a system of generators, and the default templates can also be extended or modified. Yii has a built-in user authentication and authorization framework, which is easy to use and is automatically implemented in code generated by Yii. The system uses an application component class called CWebUser, and this class represents the persistent identity information of the current user. For example, using Yii AppUserIsGuest to determine whether the current user is logged in or not. Yii is extensible, not just in the typical OOP sense of being able to extend the base classes, but also Yii has a built-in class autoloading system. This means that you can easily extend Yii functionality by including other frameworks or class libraries. For example, we can add the Zend framework to the vendors directory of our web application, and then use the following code to auto-load the Zend libraries. Yii has a widget extension library called Zii, and Zii has a large number of powerful pre-built widgets, such as grid views, list views, detail views, breadcrumbs, menus and portlets, and more. Plus a number of integrated jQuery UI widgets, such as accordions, autocompletes, date pickers, dialogues, draggables, sliders, tabs, and so on. And this is all fully integrated into Yii. And this is just a few reasons why and how Yii is such a powerful framework, but there are many, many more besides. So let's go and get stuck in. Hello. In this session, we're going to run through the prerequisites for a Yii development environment, and then download and install Yii. First of all, we need a working LAMP or WAMP environment. I'm using WAMP Server 2.2, Apache 2.2.21, PHP 5.3.10, MySQL 5.5.20. PHP extensions, you'll need PHP MySQL, PHP PDO MySQL, and PHP GD2. Apache modules, I just use the default installed modules. The IDE, I use NetBeans as my main IDE. It's free and it has built-in support for context-sensitive help, MySQL and SQL. NetBeans also has a built-in database management tool which supports your day-to-day SQL needs. My preferred SQL management tool is called SQLyog, which comes in either a free or professional version. I find the database syncing on the Pro version invaluable and saves me a huge amount of time. It also has a very powerful SQL editor and formatter, and a database schema designer as well. Of course, there's also PHP MyAdmin and SQL Buddy if you rather use those. This is just a quick tip. You'll notice that I use a fully qualified URL, and I do this by changing the host file, and on Windows you'll find it in System32, drivers, etc. And then also in HTTPD virtual host file, I define a virtual host with the same URL. Okay, so let's go and download Yii from yiiframework.com. It's downloading. I'm going to open the file. You get a tar.gz, and I use 7-zip to extract that. Within my development directory, I'm going to create a directory called Yii. Note this is not my web root directory. And then if we go into the downloaded directory, we'll see there's 3 directories. Demos is got 4 demonstration applications, and then the framework is where the Yii software is held. So we're going to copy that and move it into our blank Yii directory. There we go. And then just have a look in there and you'll see there's all the Yii source code. So that's Yii installed. Now we're going to go back to NetBeans and tell NetBeans about Yii. So we go into Tools Options, onto the PHP tab, and add the Yii source code as an included directory. And that way it will be able to pick up the context-sensitive help for Yii. And there we are. That's it. That's Yii installed. So in our next session, we will create our first web application and configure it to use this version of Yii. In our last session, we downloaded and installed Yii, and in this session, we're going to create our first Yii web application and change the structure of the installed directories to a more secure configuration. Firstly, we use a Yii command to generate the web application skeleton directory structures. and it adds the necessary bootstrap and configuration files, and this makes it much quicker and easier to start development. First, we open a command prompt using our favorite shell. I'm using Windows, so I use the Windows command prompt. Navigate to your Yii install directory that we created last time, and then run the Yii command yic web app and then path to the web app. Let's have a look at the directory that it created. You'll see 5 directories. Assets is used by Yii to publish asset files, and that is static files from our Yii application. CSS images and themes are all required in the web root at runtime, must be visible by the browser. And then the protected directory contains our entire Yii web application. And it doesn't need to be in your web root. And in fact, in a production environment, it's far more secure to move this out of the web root. And also, I like to do this in my dev environment as well, as it gives easier access and better version control. We're therefore going to change our directory structure as follows. In my development directory, I have a directory for each project, and then within each project I have the protected, a runtime, and a www webroot directory. And then I have my Yii framework directory, which is shared by all my development projects. So in my photo gallery folder, I'm going to create 2 new directories, runtime and www. I'm using Windows 8, so that's Control-Shift-N to create a new directory. I'm then going to move assets, CSS images, themes, and PHP files into the web root. We then need to go into the web root and change the bootstrap index.php file to reflect this revised structure. So in here we can see the first line is pointing to the Yii directory, so that's down 2 levels, and then the config file is down 1 level and then within protected. Whilst we're in the bootstrap file, let's have a look at the other lines. Line 8 defines the debug state, and on a production server would set this to false. And then line 9 defines how many levels of the call stack will be reported in the trace logging, and we'll be looking at logging in more detail in section 7. Line 12 includes the Yii bootstrap file, and then line 13 initializes and calls the Yii application. For development, I normally add a small function here in the bootstrap to make dumping variables into the log file much easier. So I'm going to paste in my little function, dump to log, and then save the index.php file. I'm then going to go to my virtual host and just make sure that my virtual host directory is pointing to the right place and save that. And now let's see if that works. Just a quick tip, if you change your virtual host file, you'll need to restart your Apache service. Just waiting for it to go green. There. Here you can see our blank application created by Yii. You'll see that it's fully functional application with a home, about, and a contact form, and even a user login. The user login works, and we can use admin to log in. And at the moment, there are no admin-only functions, but this is what we're going to add in future sections. So there we are. We have our fully functional, working first Yii application. There are a number of third-party Yii boilerplate projects which can be used to build skeleton directory templates, much like we've manually done in this section. So try Googling Yii boilerplates and you'll find a wealth of information on how to use these third-party add-ons. Also, for more complex projects, you may wish to look into Composer, which can help you manage dependencies within your project. So in this session, we've used the Yii command yic to build the skeleton of our first web application, and we've seen how to modify its directory structure to create a more secure development environment. And in our next session, we'll be looking at how to configure our web application. Hello! In our last session, we created a blank but fully functional web application using the Yii command line. In this session, we're going to look at the main configuration file and update it for things like database access, URL management, and logging. So let's open our first application configuration file. I've set up a new project in NetBeans with the home directory pointing to my project root directory. We'll find the config file in protected config main.php. Base path sets the base path of the application component and should point to the protected directory. But as we've restructured our directories, we need to paste in a little bit of extra code here to tell the system where our web root and our runtime paths are. Name, here we can set the name of the application, which can be used in the site layouts as a heading, using Yii app name. Yii uses the auto-loading features available since PHP 5.3. Other Yii core components are preloaded automatically at application load, so we don't need to worry about those here. Import. The import function scans the specified directories and files. The class files will only be loaded when they're first required, and not before. Modules within Yii are self-contained semi-autonomous applications. That is, they don't need to relate to your application, but your application may relate to them. G, here we're going to enable G, as we'll be needing it in the next session to generate our base application. It's not recommended to activate G on a production website. Components are the fundamental building blocks of Yii, and will be an instance of the C component base class. No changes to make to the user. The URL manager, we briefly discussed URL management during the session on MVC information flow, and there I mentioned that we're going to modify the default URL structure to something more user-friendly and SEO-friendly. Well, this is where we're going to do that. So the default URL looks something like this, and we're going to change it to look more like this. So we uncomment the block of code here, and then we add script name false to remove the index.php part of the URL. And we're not going to change the rules, we'll keep the default rules as this is in the format that we're looking for. Database. We're not going to use SQLite, we're going to use MySQL. So we need to create a new database, and I'm going to use SQLyog, but you can use any MySQL tool like PHPMyAdmin or the MySQL command line. And I've created a separate user in MySQL called Photo. Within SQLyog, I create a new blank database, and I'm going to call it Photo Gallery. We then go back to our config file, and we use these parameters to populate the Yii config. So the database name is Photo Gallery, the username Photo, and then we use the password for this user, which is Photo21. And then I'm going to add two more parameters to enable SQL logging, and that will dump PDO parameters out with our SQL statements in the log files. Error handling is the URL of the default error handling form, and we'll leave that as it is. Logging, we can set up different routes to output different information. Here we see a file log route, which is outputting errors and warnings. We're going to uncomment the C weblog route and output info, errors and warnings to the C weblog route, which is displayed at the bottom of the web page and is very useful for instant debugging. And then we are going to add trace information to the log file route. So if we want to look at more detailed debugging information, we can go to the log file. If you're a Firefox user, you might want to check out the Firefox debug extension. And then lastly, parameters. We can define here system-wide parameters, which you would access using Yii app params parameter name. Hello! The application that we're going to build together is going to be a photo gallery website. Users will be able to register and then create albums, upload photos, tag albums and photos, and comment on other users' photos. Our goal will be to create a fully working application as quickly and with as minimal amount of changes to the generated code as possible. We'll use standard HTML forms throughout. As we're going to be using an agile-style iterative development method, this first iteration could be our customer prototype, which would be shown to the customer, the business flow discussed, and amendments planned. As HTML4 only allows a single file upload per form, we'll be using a jQuery plugin to upload multiple photos. Okay, let's go and have a look at our data model. As you can see, we'll be starting with a simple but flexible data model, one that we can easily add to and enhance in the future. Our principal entities are the album and the photo. Both albums and photos will have tags. We'll have authenticated users, and photos will have multiple comments. The album will allow multiple photos. It'll have a field representing a comma delimited list of tags, and it will belong to an authenticated user. The photo will belong to an album, can have multiple comments, have a field for a comma-delimited list of tags, just like the album. It'll have a sort order, captions and alt text. The photo file will be held in the file system, not in a blob field, so we'll generate a unique file name on photo upload. We'll also crunch the uploaded file into a thumbnail and store that within a subdirectory. Comments will belong to a photo, have text content, and be added by an authenticated user. You must be registered and logged in to add a comment. And we'll enable future enhancement to approve or trash comments. Tags will be very simple. It'll hold the tag name and hold the frequency of use, the number of times that tag has been used. Users will be free to register and automatically activated. Validation will check that the email is in a valid format and unique on the system, and we'll send a welcome email upon registration. So before we actually start to build our application, there are a few tasks that we need to do. If you haven't already downloaded the project files from the PAC website, you need to do that. We need to create the database, and you'll find the MySQL database creation script within section 2, protected data. So we open that and run it in our SQL tool, and it will create all the necessary tables. And as we can see here, it's inserted a small amount of test data as well. And also within the zip file, if you navigate to section 2 and copy the contents of the www directory into your www directory, this will give you a few sample photos and also the beginnings of a custom theme, which we'll discuss in more detail in section 6. Hello. In our last session, we looked at the requirements and data model for our application, and I also mentioned that we'd be developing in 2 iterations. Our first iteration will be accomplished in the next 3 sections, and we'll aim to change the minimal amount of code as possible to illustrate how quickly we can prototype an application. In this session, we're going to generate our application using the Yii module called Yii. So let's call up Yii and get started with generating our application. First, we generate a model. We're using a table prefix of tbl_. And let's start with the album table. Model class is album, preview, and then generate the files. So that's the album model created. Now we'll create the CRUD forms. Model class album, controller ID album. Preview shows you all the files that will be created, including the album controller. Click generate, and it creates all the files. We now need to do that for all the other entities in the database, the photo, the tag, the comment, and the user. Okay, so now that we've generated all our files, let's go and see how it works. We've already seen the base application, and in fact at this stage it doesn't look any different. We don't have any menus for what we've just generated. Let's navigate manually and have a look at the album forms. The first thing you might notice is that we didn't specify an action in the URL, just the controller album. Each controller has a default action, and by default it is index. You can override this in each controller using the variable default action. So in this case, the controller has run the index action, which presents a list of all the albums. We've only got one album in our database here. Clicking on the ID field takes us into the view form for the album. Again, you'll notice a slightly unexpected URL. If you look closely at the URL manager rules, you will see that the first rule converts controller/ID to controller/view. If we now use the menu on the right and click on Manage Albums, it takes us to the login screen. But why would it do that? This is because this menu entry has been defined as authorized access only, so it's diverted to the login screen. We can log in either as demo for an ordinary user or admin at the moment for an admin user. So let's log in as admin, and now this diverts us back to our original request. The admin screen is a grid view, and we'll look in more detail at grid views in section 3.4. It's an extremely powerful widget that uses AJAX calls to update itself. Let's hop across to the photo grid view, as we've got a little more data in there. As you can see, the grid is sortable on any of the displayed columns and searchable. This uses Ajax to update the table. We can define actions for each row, so let's click on the update form. Not very pretty, but at least it works. The grid view also has an advanced search form, which provides access to all the fields in the table. It can be simply customized and will also take some simple comparison operators. So we've seen how to use Yii, how to generate models, and then how to generate the CRUD forms. And we've cycled through all our table entities and generated our whole application. So in our next session, we will start looking at the code and diving in and changing some. In our last session, we generated our application using Yii. And in this session, we're going to start by looking at the data model in more detail. And then in the rest of section 3, we'll begin tailoring the application to suit our needs. As we've seen, a Yii application is split into CRUD actions for each data model. And the basic functions like list and view are available to all users. And then the create and update functions are restricted to logged in or authorized users. And the delete function is restricted to an admin-only user. In our application, we're going to use this structure to divide the front-end browsable website from the maintenance functions for data belonging to each individual user. For example, I'll be able to create and update and delete my web albums, but only view yours. Back in section 1.4, we discussed the structure of an MVC application and saw that the data model is the interface between the controller and the database. Data models will extend either a Yii ActiveRecord object or a Yii form model object. The Yii ActiveRecord object encapsulates, that is, contains, much of the database functionality that we'd have to write in a traditional PHP environment. And each AR class represents a database table, e.g. the album model holds the attributes for the album table. And each time we instantiate a model, it'll hold a single row of that table. For example, if we create a new album model, we'll create a new instance of the album ActiveRecord class, and this will hold one row from the album table. The AR class uses methods to represent the CRUD operations, such as model save, to update the model in the database. So to create a new record, we could use the following code. The data model holds many aspects of our database design, such as field validation, data relationships, model behaviors, that is, where we have common code shared across multiple models, and scopes. And as we previously mentioned, the data model is where we also store business rules and logic. Some of this may be within the validation routines, but also with specific routines such as enforcing relationships, calculations, searches, and so on. We'll be discovering different aspects of our data model in more detail throughout this course. The Yii form model object is used where we need to capture information from the user, which doesn't directly map to our database, and a simple example of this would be our login form. Otherwise, the Yii form model object follows a similar pattern to the ActiveRecord object, in that we can apply validation and other business logic within the class. However, as you might expect, it doesn't contain CRUD operations. So in our controller, the Yii Active Data Provider object provides data in terms of ActiveRecord objects, one instance of the object for each row, which is represented by an array of objects. Thus, the following code will provide an array of album AR objects, one for each row in the database. And then we can process each row with a for each loop in the following format. The Yii Active Data Provider object encapsulates this functionality for us. And thus we can simplify our code even further by creating an album data provider and then passing this to our view. The view can then iterate through the records itself. So in this session, we've been introduced to the data model and its two data objects, the Yii ActiveRecord and the Yii form model. And in our next session, we'll see how the ActiveRecord object is used in real life So we've been introduced to the data model and the Yii ActiveRecord object. And in this session, we'll see how we use these objects in real life and then modify our first view. When we generated our application in section 2.5, we saw the photo index view, and it displayed a list of photos like this. And in this session, we'll be changing the photo list to look like this. So let's start by looking at the photo controller, and we'll navigate to the index action method. Here we'll see that a Yii ActiveDataProvider object is used to read all the records from the database. The Yii ActiveDataProvider object provides data in terms of ActiveRecord objects. The array of objects is then passed to a view called index. And if we open the view's album index.php, we can see that this uses a list view to display the contents of the active data provider. And the list view widget takes its layout from another view, and in this case, it uses the underscore view. The underscore view is a very simple form that displays a label and then the field contents for each attribute. So let's change this to display the image with the caption overlaid a bit like this. So we can remove all this label and field coding here and replace it with some divs. We're going to use the CHTML component, which provides a collection of helper methods to generate various HTML tags. The first we're going to use is the link method, which takes up to 3 parameters: the text or image that we're going to wrap the link around, the URL of the link, and the third parameter is an array of HTML options, and here we're using the rel and title properties. We're then going to replace the link text with another CHTML method to generate an image tag. The image method creates an image and takes similar parameters: the image, the alt tag, and the HTML options, and in this case, none. So let's have a look. Now that doesn't look anything like the picture on the box. That's because I cheated a bit. I've already created some CSS which we need our project to use. You should already have downloaded the code for this project from the pack website and copied the www directory over the top of your www directory. And this will give you a new theme, and we need to tell Yii to use this new theme. So we need to change the Yii config file, which you'll find in protected config main.php, and include the line theme equals photogal, which is the name I've given to this theme. Now let's try that again. That's a bit better. Lastly, we won't be needing this side menu here, so we'll remove this by changing the layout for this view. In the controller index action, we set the layout variable to the layout that we want to use. Now let's go back and try that again. That's a bit better. Now we'll be looking at themes and layouts in more detail in section 6.1 and 6.2. So we've seen the Yii ActiveDataProvider, which read all the photo records from the database and passed these in an array of objects to our view. And then we updated our view using the CHTML object to create some HTML elements. In our next session, we're going to include a JColorBox plugin and also some JavaScript. Hello! In our last session we modified our photo index view and saw the CHTML object in use. In this session we're going to install a Yii third-party colorbox extension to display individual photos in a colorbox. And also we're going to parameterize the uploads directory. So our index view displays the images in a grid pattern, but when we click on a photo it just displays that photo as a raw JPEG, which is not very pretty. And wouldn't it be nice to have a color box here? For this, we're going to install a third-party extension from the Yii extensions library. So we go to the Yii framework extension, JColorBox, and download the latest release. We unpack the zip file and copy the color-powered directory into our protected extensions folder. So that's all we need to do to install this extension. Now in the views photos index.php, we add a line to create an instance of the JColorBox. Notice the syntax here. The colorbox has been created as a Yii widget. And if we look at the code, you can see that it extends the widget class. And Yii uses an alias syntax where application points to the protected directory. And then we reference extensions color-powered jColorbox, which points to this specific code. Having created an instance of the jColorbox widget, we can then assign properties or call methods. And in this case, we're going to add our images to the color box after the form has been rendered. And you can see the jColorbox page for more specific details. Okay, we'll save that and refresh the form, and then click on a photo. And yes, we have a color box. So next, you'll notice that the captions are hidden here. So we'll add a small jQuery script to slide these in on mouse hover. So we go back to the index view, and at the bottom we're going to add a section that uses the application component called client script. And this injects JavaScript. And I've specified here that it should be injected into the onDocumentReady position. The actual jQuery JavaScript I'm using is standard, so I'm not going to explain that here. You can also use the client script application component to manage style sheets as well. So that's it, and let's go and see how that looks. So in our last session, we hard-coded the URLs of our images to the /uploads directory. But directory naming and placing is really a deployment issue. So we should really put this in a configuration file somewhere. To do this, we're going to use our main config, protected config main.php, and scroll down to the bottom, and you'll see a params array, and we'll add an entry for uploads. Now we need to go and change the code to use this. However, we shouldn't really put this in the view, as it's not a presentation task, it's more a business rule, and so belongs in the data model. Therefore, we're going to create two new functions in our photo data model, getURL and getThumbURL, to return these values. So first we add a private variable to store the uploads parameter, and then in our helper function we check if it's empty, and if it is, we fetch it from the application component. And then we add our two getURL functions that use this function to build the image and thumbURL. And save that. Okay, so now we can go back to our view, which was the photo_view view, and we change the CHTML image to get the thumbURL from the model, and then the link to use the image URL. Okay, so that should do it. Let's go and check that. So I'm going to refresh the page and then use the Chrome inspector to check the image path. And yes, that seems to work all fine. So in this session, we've added a third-party extension, and we've seen how to include JavaScript using the client script application component, and how to store and retrieve parameters from the main config file. Hello! In this session we're going to look more closely at the data model and how it simplifies database queries and how we can use it to encapsulate business functions. Before we start though, there are a couple of housekeeping tasks that we need to perform, and you'll find these in the downloaded code for this section in the README file. So if you're following with the development, please pause this video and complete these tasks first. So we've added two new columns to our database, and so we now need to update our data model. So we'll open the models album.php, and the first thing we need to do is to create validation for these columns. The description is a text field of 1024 characters, and so we'll check that it doesn't exceed that field size of 1024. And we'll also add a regular expression to make sure that it only contains basic characters. The category ID, for now, we'll just add a simple integer test, but we'll come back to this in later sections. We can also delete the validation of the created date, as this field isn't input by the user. Our next task is to add these to the attribute labels method. And then in the search method, we'll add the description but not the category ID. The search method will only be used in admin functions where a user will only see his own albums and thus will not be publicly available. So we can limit the search columns to only those that the user himself will want to search on. So we'll delete columns such as ID, created date, and the owner ID as well. Okay, so that's all we need to do to add these columns. Now when we create an album model, we'll need to populate some attributes with default values, for example the created date. The ActiveRecord class has a number of events which are fired, like before save, after find, and after delete. So we could use before save to populate the default fields. So we define a function before save, which is overriding the parent before save. So at some stage we must trigger the parent before save as well. So let's do that first. We can then check if this is a new record or an update using $this is new record. And if it is, we can populate the created date. And also we could populate the owner ID with the current logged in user ID. Okay, that will do for now. We'll be coming back to events in section 5 and 6. Relations define relationships with other models in the same way that you would in a database, with the four main types being belongs to, has many, has one, and many to many. Some of these were already defined by Yii, and they provide a useful template for our further use. The many-to-many relationship would use an associative table on the database, through which the many-to-many join is made directly within the Yii ActiveRecord. Scopes. A scope is a way to predefine selection criteria and can be used with your ActiveRecord like this, where shareable is a name scope. We define this in a method called scopes. So in our controller we could use the following statement to limit our query to only shared photo albums. We've seen how the data model is used to encapsulate business rules like validation, and how it can simplify tasks such as relational joins within PHP. And in our next session we'll carry this knowledge forwards into the create and update actions of our controller. Hello! In the last session we examined the album data model and updated it to include 2 new columns, and in this session we're going to carry those changes through to the create and update actions. Let's look at the album controller and see how we use the model in a create and update scenario. When we want to create a new album, we create a new instance for the album ActiveRecord model and use this with our create form. The create form is the same form as used by the update action. When we post this form back to the create action, the post variable contains an array, as you can see from this screen capture. The ActiveRecord class has a facility to massively assign the post album array to the corresponding attributes into the album model. And the save method then triggers the validation rules defined in the model, and the save will fail if any of the validation fails. In this case, the create update form is recalled. Otherwise, the user is redirected to the view form. We've already seen the use of CHTML to generate HTML tags in our views, and the same applies in our update forms. We can use the $form text field, which is an instance of the active form class, or we can use CHTML active text field directly, both of which will change the class if an error is detected, which visually turns the field red. We can also easily enable AJAX validation by setting the Enable AJAX Validation option in the form to be true, and then uncommenting the Perform AJAX Validation option in the controller. When we do this, each field is validated on losing focus. When create and update actions have successfully saved the data, the flow is diverted to the view form. For me, this isn't very user-friendly, and I'd rather remain on the update form with a confirmation that my data has been safely saved to the database. To do this, we could use a facility called flash messages, which are messages that are written to the user section and therefore can be read across controller boundaries. So in our create and update controller actions, we're going to add flash messages for successful and unsuccessful saves. And then in our form, we can display those messages at the top of the form. I'm going to use the flash name to also control the style, which has already been created in our theme, PhotoGal. Whilst we're in the form, we can also tidy it up. We'll remove the ID and the created date, and we'll change the shareable field to a checkbox. And then we'll add our description as a text area with HTML options for columns and rows. And then I'm going to remove this mandatory fields paragraph, and then save. Okay, let's have a look at those changes. So I'll create a new album and let's call it Villages. And then I'm going to add a description that is way too long and it will return a validation error message and the field goes red. And then I'll make it valid and save the record. And we'll see the flash message showing a successful form save. And the same will happen with the update form. Okay, that's looking quite good. Now I'm going to set some homework for you. We're in a position to tidy up the underscore view and the view views used by these two methods, much like we did with the photo albums back in section 3.2, removing fields that we don't want to display and also using our new fields. Here are some suggested layouts with class identifiers that have already been added to the PhotoGal theme. So good luck with that, and if you don't get the chance, they'll be available in the next section's download. So we've seen how Yii uses the data model in the create and update actions, and how we can use flash messages to display within or across controller actions. In the next section, we're going to add a subform to display photos within our album display. Hello! In the last session we looked at the create and update actions and how they worked, and also tidied up the update form. In this session we're going to embed a subform in our album view to display all the photos for that album. For this we'll be using the updated view and underscore view views from our homework. So if you haven't been able to complete this, then you can use the views and the user model from the section 4 code download. Basically we want to embed the photo index view into the album view. So if we start by looking at the photo/index action, we can see that we have used a CActiveDataProvider to extract the photos from the database, and then pass this to the index view. The index view uses a CList view to display this data. So in our album view action, we need to also use a CActiveDataProvider, but only one that extracts the photo records for this album. And this would be in the SQL form of select star from photos where album ID equals 1. We can copy the code from the photo controller and then add a criteria with a condition of album equals and a parameter of the current album ID. So we need to pass this data into our view, and then in the view we can add a call to the photo index view. Question: is it okay to cross model boundaries like this, calling the view of one object from another? Personally, I think if this view is regularly used in the photo model on its own, then yes, there's no point duplicating it. Otherwise, we can move this view into the views album folder and call it something like underscore photo and just use it locally. Now let's just go and check that. And oops, we get an error. This is because anywhere you reference a link or a view, Yii assumes it's within the bounds of your current controller unless you specify the controller. So in the render partial we just used, we specified photo index, and if we look at this view, we can see that it uses a CList view, which takes its format from just underscore view. Well, Yii's looking for this view within our current controller, which is the album controller. So it's picking up the views album underscore view, not the views photo underscore view. So we need to change the CList view to use the absolute path, which is /photo/underscore view. And there, it's happy with that now, and that's doing what we set out to do. Next, we're going to add a comment count for each photo to look like this. So this would be in our photo underscore view that we've just been looking at. So how are we going to reference the number of comments for each photo? Well, we can use a relation to do this. One of the relationship types is called stat. The stat relationship will perform statistical or aggregated queries on related objects. You can only use statistical queries on has-many or many-to-many relationships. In the photo model relations function, then, we define a new relationship, and let's call it comment count. It's against the comment table using the foreign key photo ID, and then we need to include the status of the comment, as in the future we might enable approval and trashing of comments. So we'd put status equals 2. But putting status equals 2 isn't very maintainable. So we could define some constants in the comment model: status pending, status approved, and status trashed. And then we can use this in our relation. So let's change the relation status to status equals comment status approved, which is much easier to read and maintain. Now back to our photo view, we can use the very simple statement of $photo comment count to display the number of comments. And that's it. That looks great. So in conclusion, we've seen how to embed a subform and populate the data for this form from the related model. We've also seen a new relationship type of stat and used it to count the number of related records. In our next section, 04, we're going to be looking at automated testing with PHPUnit and Selenium Server. Hello! In this session we'll be looking at the advantages of automated testing and how Yii integrates these tools into the Yii environment. We'll understand what the benefits are of implementing automated testing tools, whatever the scale of your development or the role you play. Many of us, me included, are not too keen on testing, and often it gets bumped down to the bottom of the list of things to do. And for this reason alone, you should implement a realistic testing strategy. If you're a lone developer, like me, or just developing a small application, you may think that this section is not so relevant, that the overhead of getting started is too much, or I just don't have the time at the moment, I'll do it later. I've been there and done that, and from this experience alone, I'd strongly advise you that this is equally relevant to you not just today, but more importantly next year, when you come back to this application to do a small change, and you've forgotten some of the internal dependencies, or the system's now grown by a factor of 5 and your small change at one end seems to break something at the other end of the system. And then the next thing you know, your client's on the phone saying, "Help, the system's crashed." And when you get to this stage, it might feel that it's too late to start. Well, that's where I was 2.5 years ago, when I started my first Yii application, which just grew and grew, and now I'm slowly backfilling all those testing gaps. Yii is superbly integrated into PHPUnit, and on Linux at least, it's pretty quick and easy to set up. PHPUnit supports 2 types of tests: unit tests, which are designed to test individual discrete functions within your code, and function tests, which are designed to test the overall functionality from the user's perspective, using PHPUnit and Selenium to remote control a browser and then check the output. Also, as you can see in the background, we can now run all our testing from within NetBeans. There's no need for that nasty command line. So have you thought about using a TDD, a test-driven design approach? Why would this be a good idea? Just imagine that we're developing a customer ordering system. Imagine if the tests were the first thing that we did, that we developed a testing routine to test the validity of a shopping basket. Does the item need an option? Has the customer chosen the right color, the size? Is it in stock? Are the totals correct? Has the correct tax been applied? Is shipping calculated correctly? You can then run these scenarios by your client, who can look at it and say, no, it doesn't quite work like that. It should be like this. And that's before you've even cut all that code and have to go back and change it all. Our tests can then become integrated into the specification. And when we code, wow, is it so easy to check. So does that sound too easy to be true? Well, let's see. So in the next video, we'll run through a quick install of Pair, PHPUnit and Selenium, and look at how Yii hooks into these environments. Hello, in this section we're going to run through the installation of the testing tools that we need, and also make the necessary changes to our application test bootstrap and config files. We'll demonstrate how quickly and easily we can set up and configure our test environments. I'll be stepping through the installation on an Ubuntu server, and you may have noticed that I develop on Windows, but I'm going to be using Ubuntu for testing for 2 reasons. Firstly, I prefer to separate my development and testing environments, and I do this by using a VirtualBox for testing. And I found that PHPUnit on Windows is difficult to install and not always very stable, and I get much better results running it on Linux. Therefore, I set up a Linux VirtualBox to do my testing on. We start by installing Pair using apt-get. The steps are pretty similar on Windows, and I'll point out the differences as we go along. And then it's a good idea to check that your Pair channels are all up to date, and that Pair is itself as well. We now set Pair to auto-discover. So we now install PHPUnit through Pair, and then we need to install curl using apt-get. We're now going to install some PHP additional modules, starting with skeleton generator, and then Selenium server, and then invoker, and lastly story. We then need to restart Apache as we install a new PHP module, and then we can check that PHPUnit runs OK. Oh voila, it all works. Next we need to download Selenium server. OK, that's downloaded. So open gedit.bash rc and navigate to the end, and then insert an alias for Selenium. We'll then be able to run the Selenium server by just typing Selenium. We now need to set up our Yii application to use PHPUnit. Yii runs a test through a different bootstrap file. Rather than using index.php, it'll use indextest.php. If we open this file, we can see that it looks much the same as the index.php. It uses a different config file. So first we need to get it to point to the right directories. I'm going to just copy those lines from index.php. Now if we go and look at the test config file, which resides in the same directory as the main config file, protected config test.php, we can see that it includes the main config file and then adds a fixtures component. So here we're going to tell the system to use a different database. We copy the database component definition from the main config file and then paste it in here and change the database to point to our new test database. Okay, now we just need to check the PHPUnit config and bootstrap. So we go to protected tests again, and we'll see three files there. PHPUnit.xml is the PHPUnit config file. And all we need to do in here is define what primary browser we want to use, and I've changed it from the default IE to Firefox. You'll notice that the first line of the config tells PHPUnit to load bootstrap.php. So we need to change this in the same way that we changed indextest.php. And then the webtestcase.php, we need to change it to specify the URL of our test system. That's it. It should all work now. So in this session, we've seen how to install and configure our testing tools on an Ubuntu server, and how to configure Yii to use these tools. And in our next session, we'll be creating some automated unit tests and running these through in NetBeans. Hello, in this session we're going to create some unit tests with PHPUnit. We'll learn how to produce and run PHPUnit scripts, and then analyze the results all within NetBeans. At the end of section 2.4 I suggested some homework, within which we needed a function to concatenate a user's name, not forgetting there that either the first name or the last name could be blank. So we can create a unit test for the user model, and the expected naming convention is model name test. So we create a file called usertest.php, and we use a class of userTest which extends the ctest case. Unlike controllers that have methods called actionSomething, unit tests have methods called testSomething. So we'll create a method called testUsername and then add some tests within that method. But before we go any further with that, we need to define some test data, and this is how mine looks. First, we want the system to load each user and then check that the fullName method of the user model returns the correct value. So we can wrap this part into a function, and I'll call it getUser, where it loads the model and then returns the result of the fullName method. And then going back to our testing method, we use a method called assert_equals to check that the returned result equals an expected result. So we enter our expected result first, followed by the return value of the getUser function. And then the third test, I'm going to make a mistake and put in an extra space. So we save the file, and then we right-click it and run. We then get the results in NetBeans output window, and it's showing us an error in a diff-style output. You can see here that it's highlighting the differences between the expected output and the actual output. So let's go back and correct that. And there we are. Run it again. And it reports OK on one test and 3 assertions. We haven't yet examined the model search function in detail. but it returns an array of model objects by building a query based on the value of its attributes. So if we set $model email to equal user, it would build a query like select star from table user where email is like %user%. That's fairly simple, but I'm sure you could imagine that it would get pretty complex when you start adding relations. So we're going to build a test for the user search function and check that the model search returns the same as this SQL. So first we would run a query to return the records directly from the database, and then we can create a new instance of the user model, set the criteria email equals user, and then get the data. However, this isn't going to work straight away because the search function returns an array of objects and the PDO array has a distinct structure itself. So I've built some functions to convert these arrays, and I put them in a class called myTestCase, which extends cTestCase. So if we change this class that we're working on to extend myTestCase instead, we can then use these functions across all test cases. And then we change the test function to use these two functions. And then run the test and check the results, and all okay. So in this session, we've seen how to create and run unit tests using PHPUnit to test discrete functions within our Yii classes. And in our next session, we'll be looking at how to maintain data integrity across testing sessions. Hello! In this session, we're going to look at two different ways of ensuring data integrity across testing sessions. Unit tests need to be repeatable, and therefore we need to ensure that each time we're running on the same data. By automating this requirement inside the unit test, we'll be removing the need to reset the data manually. The first way to ensure that your data is always the same is to make sure that you undo any changes that you've made to the database before closing the tests. PHPUnit provides a number of methods for us to accomplish this, and we're going to use the setup and teardown methods. So let's set up a test to validate our actionCreate method, thus creating a record from a post request. For this, we'll use the photo class, and I've added a before save to my class to update the created and update dates, much like in the album model. We can use the setup method to define our post variable in a post array like this, and then we create a test method, test_insert, to create a new instance of the photo model, massively assign it against the $post array, save, and then check the results. And we also need to have some way of deleting the records we've created. So here I'm going to save the ID of our new record in a class level variable. And then we define our teardown method, which will check that the ID exists, and then delete the record. Okay, let's try that. And you'll see that we get a failure. But looking at the results, we can see that we should, in fact, have expected a fail, as the photo model has ID, created date, and updated date all assigned, whereas these weren't even mentioned in the $post array. So we could correct that and rerun, but let's check the database and see if our record really has been deleted. And yes, there's no sign of the record there. So that's the teardown method. Another way is to use fixtures. Fixtures are a way of setting the table to a known state. And in Yii, this is implemented by using an array to populate the table at the time the test class is first instantiated. So the fixture for the photo table would look like this. To get the class to use fixtures, we have to change its parent to CDB test case, and we can then define a public class array to limit which fixtures are applied. There's no point running all the fixtures if we're only going to check one table. So here we set the array to only load fixtures for the photo table. We're then going to define a test to check that all the photo records are read correctly, as if we were running the actionIndex method of the controller. So we load all the photo records into our model. We can check that we get the same number of records as expected, and then load our model into an array and use assert equals to check the model array with the array populated by the fixture. So let's run that and check the results. And we still have the array error from the first test, but our second test ran okay. And if we look at the database, we'll see that the table has indeed been reset. Here you can see the fixtures had alt text defined, whereas before we didn't. So in this session, we've seen two different ways of maintaining our test data across multiple tests to ensure that we're always running our tests on the same data. Firstly, we used setup and teardown methods And secondly, we used fixtures to initialize our tables before running the tests. In our next session, we'll be looking at functional testing using Selenium Server. Hello! In this session, we're going to look at setting up some functional tests using PHPUnit and Selenium Server. Automating the functional tests of your application will quickly enable you to retest your pages with minimal effort. We're going to run through the photo forms, firstly the index method, and then onto the admin forms and updating a photo. So we'll start by creating a new Selenium test unit, and the NetBeans template inserts skeleton code, and we can delete all of it. We define a class photo test which extends web test case, and then define our first function, which we're going to call test_index. We open the photo page and check the presence of some text, and in this case we'll look for photos. We're then going to check the div.view if the images is present. So if we click on an image, we should get the color box. We can then check the presence of the color box by looking for a div with the ID equals cboxLoadedContent. Okay, let's save that and then run these tests. And we should see a success message, one test with 3 assertions. Now we're just going to go and corrupt the config for the color box in viewsPhotoIndex.php and just change the class so that it isn't recognized. So we rerun the test and we find that we have some problems. So great, we can fix that before we release this code. So that was fairly simple. Let's look now at the photo admin page. And if we navigate there in our browser, the first thing we notice is that we have to log in. And then having logged in, we automatically get redirected to the page we requested, photo admin page. So let's start coding a test, and we'll call it test admin. So we open the photo admin page, but then we need to log in. So we type the username into the login form username field, and the password into the login form password field. And then we press the login button, and if all is well, we should now be on the admin page. So we should check that we are there. So I'm going to check that there is some data being displayed in the table. So let's see if we can find the first photo, image1134.jpg, in the page. And we use an assert, because if we're not on this page, then the remaining test will be invalid. I'm now going to see if the sort function on the table works by clicking on the heading for the caption, which should reorder the rows by caption, and we should end up with calm after the storm as the first record. So to check this, I'm going to check that the first record being displayed has an ID of 3. Note also that we're using a wait for eval here. That's because the sort uses Ajax to refresh the table. We'll then click on the pen icon for the first entry, again using the href as the selector, and test the update page. We could then check various validation criteria, which we can demonstrate by adding some characters to the sort order field, trying to save it, and then check that the error message is displayed. So we correct the sort order, retry the save, and then check for the heading. In this case, it's view photo number 3. Okay, so let's run through those tests and see what happens. And our output should now show all successful on 2 tests and 7 assertions. For further information on Selenium commands, called Selenies, have a look at the Selenium documentation at docs.seleniumhq.org. And also a useful tool worth looking at is the Selenium IDE plugin for Firefox, which enables you to record, edit and debug web tests, all in a simple IDE. So in this session, we've seen how to run functional tests using Selenium Server and PHPUnit, and how functional testing really can save you. Hello! In section 3, we completed the first iteration of our application, and we managed to rearrange the front end, the public side of the website, to look similar to our final product. Over the course of this section, we'll perform iteration 2, and we'll turn our attention to the back end, the area for registered users to be able to create albums and upload photos. Previously, we installed a Yii Colorbox extension and saw how to use it in our code. In this session, we'll look at third-party components, extensions, and modules in a little more detail, and we'll install and configure 2 new extensions to help us upload and manipulate images. Using extensions can save us a huge amount of time, so it's well worth spending a few moments browsing through and familiarizing yourself with the extensions available. HTML4 only allows a single file upload at a time, so we're going to install a jQuery extension that enables multiple file uploads at any one time and also provides a very friendly user interface. So we'll start by finding a jQuery upload extension in the Yii extensions library. And here's one called XUpload. Let's check the installation procedure given here on the extensions page, and then download the zip file. As before, we copy the contents of the zip file into the protected extensions folder. And then this one also needs renaming to remove the version number. Next, we need to configure the extension in our config file, protected config main.php. And we need to define it as an alias. And that's it. It's as simple as that. It's now ready to use. So we're also going to need to crunch our images to create thumbnails, so we can see what's available for that in the extensions directory too. So let's just look for image. Here we are. We'll use this Kahona-based extension. Let's check out the instructions and, yep, we'll download this zip file. Open the zip file, and this one's a little different. The image folder is the extension, so that goes into extensions. And then helpers goes into the protected folder. Helpers are normally just small helper functions, and this one contains some array manipulation functions. Okay, to configure this extension, first we need to include the helpers into the import array, and then we need to define the image component parameters. So the class points to the files we've just copied in, and then the driver is depending on your setup. If you've installed GD with PHP, then we can just leave this as GD. But alternatively, with this extension, you can use ImageMagick. Now, I mentioned third-party components, and we've seen extensions, and I've also mentioned modules. But what are they, and what are some of the differences between them? The simplest form is a component, and a component is a one-class file, and normally specific to your functional business requirements, and are placed in a component to share across controllers. Next in the line comes extensions, and extensions are like libraries, and will be independent of your data model and can theoretically be used across projects. Modules are a form of extension, but could be more like mini self-contained apps, and so they may have their own data model, separate from or on the side of your application. Modules will therefore also be usable across different projects. Okay, so we've seen how to search, find and install extensions from the Yii extensions library. And we've discussed how using extensions can save a huge amount of development effort. We've also discussed the hierarchy of the plugin architecture within Yii, components, extensions, and modules. And in our next session, we're going to start using our extensions by preparing the views and forms for these new extensions. Hello! In this session we'll include a widget provided by our new XUpload extension into the album update form, and this will enable us to upload multiple images at one time. We'll see how to include third-party widgets in forms, and also to use runtime configuration options to customize the widget to our needs. The auto-generated code from Yii separates functionality by data model, like album update, album create, photo view. And this is great for prototyping and setup scenarios, but more often it isn't how we work in real life. When we create a new album, for example, we'd want to add photos to that album at the same time. So if we base our functionality on the album create and update forms, and then add photo processing to them. So we'll start with the album update form, which we'll find in protected views album update.php. And we add our image upload widget in here. So we add a call to $this widget with a reference to the XUpload widget. And then the next parameter is the URL, which will be called by jQuery to initiate the upload. And we'll add this into the album uploads in our next session. The widget needs an instance of the model XUpload form. And this is really just a temporary container for the uploaded data. And then we include other options, and you can see the wiki pages for more details on how to customize this extension. And this widget needs to be wrapped in a form tag, so we'll add a form tag just above it. We could have used the form defined in the underscore form view, but I decided to use a separate form, and then end widget for the form tag. We now need to define the XUpload form model in the controller. So first we import the xUpload class, and then we create a new instance, and then pass this instance through to the view. That should work now, but before we move on, I'm just going to do a few cosmetic changes to the album_form view. So I'm just going to add some div containers around our rows, and then move some of the fields up, and then put in another div block, and then just add a class to the button. Okay, let's try that, and we should see the upload widget rendered, though there's no upload functionality behind it yet. And yes, it all works, but it doesn't look very pretty. That's because I haven't copied in the PhotoGal theme from this section's download. So I'll go to the zip file, find the PhotoGal folder, and copy it across. Now let's refresh our browser, and there we are, that's looking much smarter now. Our PhotoGal theme is evolving nicely now, and if you're familiar with the CSS Bootstrap framework, you may notice that it's now included within the theme. Okay, so we've now seen how to include third-party widgets in our views, and we're now ready to add the upload action, which we'll do in the next session. Hello! In this session, we'll be using our image upload extension and building the controller action to handle the upload request from our jQuery front end. We'll see both how to process AJAX requests and how to manage binary or image data using the cUploadedFile class. We'll also see how to create thumbnails using our new image manipulation extension. So we'll start by creating the new action in the album controller, action upload. And it'll have a parameter of the album ID. The xUpload wiki has a use case which is very close to our requirements, so we can start by copy and pasting the code from the wiki page. Now let's look at the code a little more closely. First we need to define our paths, and the physical path of the web root isn't so obvious in Yii, but we can use the path of the current script, which of course is the index.php bootstrap. And then we can add the upload parameter from our config file. The URL is easy as this is the base URL plus the uploads parameter. We can leave this bit about the headers, and we'll come back to the file delete a little later, so I'll just put some stars to remind myself. Then it populates the xUpload form model, so that's okay, we can leave all this. It randomizes a file name, and I'm happy to go with that. And then it runs the xUpload form validation. And on success, it saves the image, which for us will be the final destination, and then it runs chmod. And if you're on Windows, you could comment this out depending on your security requirements. Then we can remove all this about the user session as our workflow is a little different. And then here we can add our thumbnail creation. So our image extension was defined as a Yii component in the config file. So we can reference it using Yii app image, and then use the load method to get the contents of our already saved image. And I've added another parameter to my config file to hold the size of the thumbnail. So now we can crunch the image and also change the quality, and I'm also going to sharpen it as well. And then save it to our thumbnail directory. Now we need to store this into our photo model, so we create a new photo model, and then add the album ID, and then the file name, and then we can save it. But we should check that that save was successful. And therefore we need to duplicate this else clause. Now we go back to the delete section, and first we'll need to delete the photo record. But the only search criteria we have is the file name. So we search by file name, and then if it's found we can delete the photo, and then we also need to delete the thumbnail. Great, that should nearly do it now. But one last thing, we'll be looking at security in a later session, but for now we just need to add this action as an allowable for logged in users by adding the action name in just here. Okay, let's try that. We'll choose some photos, click upload, and yes, that's all working. That's great. So in this session, we've built a controller action to handle an AJAX upload request, and we've seen how to process uploaded images, and at the same time used our image extension to create the thumbnails. So in our next session, we'll look at the See Grid View widget to display our photo records in the album update form. Hello! In our last session, we completed the image upload in our album update form. And in this session, we'll look at the See Grid View in the album admin form and learn how to customize it. The See Grid View widget is an incredibly powerful tool, and in this session we'll demonstrate some of the ways of using and customizing this widget. The album admin action displays a list of albums, in fact a list of all albums, and in our application this should display a list of albums just for the logged in user. So first, let's take an overview of how this widget works. It's an AJAX-enabled widget, and so will refresh itself based on filter criteria or sort requests. The grid view displays data returned by a method in the data model using a data provider object. By default, this method is the search method, and in the controller, when we create a model instance to pass to the grid view, we use a search scenario. This scenario is primarily used to validate model attributes differently to those in an insert or update scenario. The grid view uses the model to store the search criteria and then build the final query. For example, by setting the model album ID equal to 1 and then running the model search method would result in the See Data Provider object having all records belonging to user ID equals 1. So in our album admin controller, we can see that it creates an album model in a search scenario, and we only want to display records for the current user, so we need to add a filter using the current user ID. We could either add this into the controller just by adding this line model owner ID equals Yii user ID. Alternatively, and better from a reuse point of view, we could add a scope to the model and use this. So let's define a scope, and we'll call it mine. So we've already used scopes, and we'll add the mine with an order of the created date, condition equals owner ID equals, and then a parameter, and we define the parameter, the owner parameter, as the Yii user ID. And then in the search function, we can set the scope of the criteria to mine. So now that should filter the query every time, so let's see. And there we can see the records being displayed belong to the owner ID of 2. Okay, now moving on to the grid view itself, which is used in the view's album admin form. The grid ID is used by the AJAX request and, as with standard HTML, must be unique in the current page. The data provider refers to the model method, which returns the populated See Data Provider object, and in this case we're using the search method. The filter determines which model instance will be used by the grid to store the filter values. Normally this would be the same model instance as the data provider. The columns can be a simple list like this, or each column can have a number of parameters, and this is where we'll start changing what is displayed in the grid. We'll remove the ID field, and we're going to change the owner ID to show the user's full name, just to illustrate a relational join. So let's have a look at that. And we'll see that the owner full name is displayed in the list. But actually we don't need the user ID, so we'll remove that. Shareable should display yes or no, so we'll change that to use a PHP tertiary function. And the created date will use the Yii date formatting class, and I'm going to put in a UK date format. So let's go and try that and see what it looks like. And we can see the formatting changes that we've just made. The columns, we no longer have the ID, we've formatted the date column. Now for some homework. If you have a look at the advanced search form and try and understand how this is posted to the same controller action, the album admin controller action. And then try using an application like Fiddler where you can see the response and request information flow. So in conclusion, we've seen how the See Grid View works and how it can quickly be customized to provide a flexible and very powerful widget. We've also seen how we can apply scopes to our data provider queries to use built-in filters. And in our next session, we'll add a See Grid View into our album update form to display the photos for an album. Hello! In our last session, we met the See Grid View and looked at how to customize it both in its layout and the data provider to supply data to it. And in this session, we'll continue to use the grid view, looking at its button column, and also how to include images. So in our last session, we customized the C grid view in the album admin form, and we'll return to this grid view and have a closer look at the button column. The C button class uses a template approach, and by default it uses tokens of view, update and delete. I'm going to replace this using update space delete. This would be sufficient in itself, but the following code will demonstrate how we can further customize each button very easily. The label is used as a text label if the image URL is not present, or if it is present, then used as the icon's alt text. The image URL is the URL of the icon, and here I'm going to use a new icon which has been included in this section's PhotoGal theme. The URL is the target on-click URL, and note the lack of controller name here because create URL assumes the same controller, thus album update, and also that you can specify additional parameters, and here I've used asDialog equals 1. Click is the on-click JavaScript event and can be used, for example, for displaying an AJAX form. Options is an array of HTML options, and visible is an expression to determine whether this button should be visible or not. Okay, so that should look pretty good now. So let's go and have a look. Yeah, that looks great. Now if we go into the update form where we added the file upload widget in session 3, we need to display the photos for this album. So we could also use a grid view here to do this. So we'll create a new form for this within Views Album and call it _photos. We can copy the grid view code from the Views Photo admin, and we just need the grid view. We don't need the advanced search functionality. So copy from here and paste into our new form. We first need to set the model name. We haven't created our data source yet, so let's just call it $photos. And we can remove the filter as it's unlikely that we'll need to filter within an album. We can then remove the ID and album ID. In the file name, it would be better to display a thumbnail of the image here. So we set the name to thumb. And the value, well, I've created a method in my photo model to format the image tag for the thumbnail. So here we can use $data get thumbnail. So now the caption alt text tags can stay, and then just add the sort order too. Button columns, I'm going to copy across the code from the update form we've just done, and then everything will look the same. And we just need to change the URL. Okay, so now we need to include this form into the update form. So we use render partial and pass it the $photos variable. And then we need to go back to our controller action, album update, and set up the $photos variable. We're using a grid view, so we need to provide the data in a data provider format. So we can use the photo search method. And so we define a new model in the search scenario. We unset any attributes just to ensure that everything is cleared. And then we need to specify the album ID. Then we add the $photo variable to the render statement. Okay, let's see how that works. Refresh the page, and it's displaying the image tag. That's because we didn't define the column type, which defaults to text. Okay, let's try again. Yeah, that's pretty good now. Okay, now there's some homework to do, and there's 2 bits this time. Firstly, we need to tidy up the photo update form. So remove the ID, the created date, the last update date. Change the file name to a thumbnail of the image. And then the second, we need to change the photo delete action to also delete the image and the thumbnail. And a hint, you can grab the code from our file upload action that we did in session 4. Great. Well, now that we're experts with the grid view, there's no stopping our development. And so coming next, we'll be looking at themes, layouts, and user authentication. Hello! In this section, we're going to look at theming and styling the application, and also user authentication and security. And in our first session, we'll look at the structure of the theme files and how the page layouts are defined. We'll learn how theme files override application files, and also how the hierarchy of views is displayed. We've already seen that we can define themes at the application level, and that we've been building the underlying PhotoGal theme bit by bit as we go. So now it's time to delve down into the structure of themes a little deeper, and how they can be adapted and extended to suit our applications. In our main.php configuration file, we set an application level parameter for the theme to point to our PhotoGal theme. And this is used on application startup to initialize the C theme manager component, which defines the current theme being used by the application. The theme holds views and layouts as well as resources, i.e. images, JavaScript, and style sheets. When you start a controller action, the controller component will look for views and layouts in the currently active theme before looking in the application protected folders. For example, if we define a photo index view in our theme, shown here, then this will override the version in protected views photoindex.php, and thus the themed view will be rendered. Using the theme CSS files, we can style our application in the same way that we would style any web page. Now let's have a look at this file, and we can see that it's the main template file for the theme, and it's responsible for the overall structure of the page. So we're going to add a new CSS file here where we retheme the core Yii widget classes. And we can see the standard Yii included files at the top, followed by some theme files already present. Firstly, the bootstrap.css, which I mentioned I had added in our last section, and then followed by the general theme style sheet, screen.css. So here we can add a new CSS file which is called form.css, which has been created to retheme the core widgets. Okay, so let's save that and see what it does. Great, that seems to work well. So going back to the main layout, we can see that it uses a menu widget to display the main horizontal menu. And we'll look more closely at this widget in our next session. It then displays a breadcrumb, if present, and then it echoes $content. You may expect the $content to be the results of the render statement, but before that there's another layer of templates called layouts. The default layout can be defined within each controller, and as the name suggests, is responsible for the layout of the content section, single column, multi-column, etc. And if we look at a layout file and go to protected views, let's have a look at column1.php, you'll see that it also echoes $content. You may have already noticed in previous sessions that we use $thisRender and, in some cases, $thisRenderPartial. As you can probably determine, the render forces the generation of the full page using the content and layout elements, and RenderPartial does not. And in fact, if you look at the render code, you'll see that the render uses RenderPartial. So the following diagram summarizes the hierarchy very nicely. And here you can see the rendered view is passed as $content to the layout column1, which is then passed as $content to the layout main. And that is why we see $content in both the layout and the main. So in this session we've seen the structure of theming files and how the templates are made up from the main layout, then including content layouts, which in turn include rendered and partially rendered views. And in our next session we'll customize the main layout. Hello! In our last session we looked at the structure and files that make up a typical Yii theme, and in this session we'll modify the navigation widgets in the default theme layout. We'll see how we can alter the available navigation items for authenticated and guest users. So if we open our theme layout file in www.themes photogal layouts main.php, we can see here that the main menu is created using the C menu widget, and that the menu items are represented by an array, and each element of which corresponds to a menu entry. The commonly used option names are label, URL, which represents the link, visible, which is a boolean and often set to something like isGuest or isAdmin, and then the items to define submenu entries. So I'd like to create a separate user menu navbar using another instance of the C menu widget, and then keep this main navbar for more generic options, to look something like this. So we'll create a div to hold this new menu, and I just happen to already have created the styles for this div, so be sure to copy in the new theme files. And then we'll create a menu using the C menu widget, and then if you haven't logged in, all you would see is a login menu. So there are two ways we could do this. On this entry we could use the visible option and set it to when the user isGuest is true. But then with all the other entries we would need to set not isGuest. So I prefer in this kind of scenario and also useful if you're building a menu from a database, to build the arrays first. So using an if is guest, and then define the array for the guest user. And then else, we can create another array for authenticated users. So first we'll display a simple welcome label with no link or URL. And then a link to display my albums, which is the album admin that we worked on in section 5.4 and 5.5. And remember that we put a filter on this using a scope called mine, so that it only displays albums belonging to the current user. And then next we could add a settings menu. And that would allow the user to change profile details and their password. So for now we can set this to user update, and then pass the ID as the current user. And then we'll move the logout option from the main menu and insert it here. And then we just need to change the nesting of the divs here to put the user menu inside the header. There, now we can clean up the main menu and remove this item. Home really needs to display all the albums, and we've already done this in the album index action, so we could just change this to point to the album index. But then what happens if a user navigates to our site root? It'll still go to the site index page. So what we really need to do is change the default controller for the application to the album controller. And we can do this by adding another option to the main config file. The option is called default controller, and we set that to album. Okay, that should just about do it, so let's go and try. We're logged out, so we get the login entry of the user menu. Click login. And yes, we get the user menu. Okay, let's check the home page. And yep, that's pointing to album index, and it displays all the published or shareable albums. Okay, so in this session we've seen how to customize the theme layout and how to change what is displayed for authenticated or guest users. And in our next session we'll start to investigate and modify the way that users are authenticated by Yii. Hello! In this session we'll investigate the Yii user implementation and see how we can change the default authentication methods to use database lookup. We'll see how Yii separates the process of authentication from the web user session, and understand how the login process manages the relationship between the two classes. The Yii user model is split into two parts, and understanding this is the biggest step to being able to customize the user session and authentication management. The login action and login form model manages this process for us and ties these two classes together. On application start, the system creates a CWebUser class, and if cookies are allowed, it checks if a cookie exists, and if so, loads the user information from a cookie, otherwise the identity is set to guest. On login, the system creates a user identity class, passing the login details. How this validation occurs will depend on your application, perhaps against a database, or login with Facebook, or against an LDAP server, etc. And the login model then passes the user identity object to the CWebUser object, which then stores this information. By default, the CWebUser class stores its information in session data. The login form and login form model were generated when we first created the application. And if we look at the site controller, we can see that the login action takes the login details posted from the login form and creates an instance of the login form data model. In this data model, the input is validated in the normal way, and then the login method is called. This method creates the user identity object, thus validating the user is valid, and then passes the user identity object to the CWebUser class using Yii AppUserLogin method. If the Remember Me box has been ticked, then a cookie is created and loaded next time the user creates a session. Back in section 3, we copied in a file called useridentity.php into the components directory. So let's take a look at that now. Our user identity class extends the CUserIdentity base class, and our class defines methods to get the username, user ID, and then we've defined an authentication method. Our authentication method checks that the username, which maps to email in our database, exists on the database, and also that the input password matches that on the database. If either of these fail, an appropriate error is returned. Otherwise, the user ID and username are loaded into the model and success returned. Here we've used a very simple MD5 encryption of the password, which could easily be enhanced for a production environment. Having created the user identity object, The login process then passes this identity object to the C web user class, which by default will store it in the user session data. The C web user class only stores user ID and username, so if we want to store more information, like user role for example, we can extend this class as well. So let's follow that through in one go. On app start, we create a web user class. If cookies are enabled, then user information, including user identity, is loaded from the cookie, otherwise the identity is set to guest. On login, the login input is validated in the usual way, and then the user identity is created and validated, and then the web user is updated with the identity information. So in this session, we've seen how the two classes, CWebUser and CUserIdentity, relate to each other, and how the login process manages the task of user authentication and updates the user session. And in our next session, we'll customize the CWebUser class to hold user role information and look at how we can also customize the login form model to validate user passwords. Hello! In this session, we'll see how to extend the web user class CWebUser to hold further user information from our database specific to our application. We will also extend the user form and model to enable the user to update their own details. We'll learn how we can quickly and easily tailor the web user class for our applications. So we've decided to add a new column to our user table to represent a user role. We'll implement this in a simplified CMS style of responsibility, where a user can be an author, a moderator, or an admin user. We will represent this in our database using an integer field. But first we'll need to add this column to our database, and you'll find a script in the section 6 zip file under protected data section 6.1.SQL. We'll also need to add this column to our data model, and we'll use constants to reflect our roles. Next, we create a new component in protected components and call it WebUser. And we define it so it extends CWebUser, and then we'll define a variable to hold the user model, which we'll load using a function. We'll call this loadModel, and it checks that it hasn't already been loaded and that we have a user ID, and then we'll load it and store it in this class level variable. Now we can create get functions for each of the attributes we want to expose. Lastly, it's often useful to have an isAdmin function, particularly as it will return a different result to not isGuest, and it will return the result of comparing it to our roleAdmin constant. Okay, we save it, and now we need to tell Yii to use this class rather than the default CWebUser class, and we do this in the config main.php file. We add an option to the user component called class and give it the class name. To test it, I've already added some var dumps to the site index view. And here we can see that the system is now using the web user class, and it's being populated from our database, and the isAdmin function is returning true, as expected. Next, we're going to add some extra validation and processing to the user model and the underscore form view, so that when a user updates their details, if the password is left blank, it doesn't overwrite the previous value in the database. And we'll also use a repeat password functionality to check that it was typed in correctly. So I've updated the underscore form view already to use two new fields, password save and password repeat. I've also removed status, create date, and last login time, and then I added a couple of block divs for formatting. I've enabled Ajax validation here in the form widget. And also in the user controller, we uncomment Ajax validation line, both in the create and update actions. Now in the user model, we define two new attributes which will store the passwords from the user form, and then we define them in the validation. Firstly, both fields need to be mandatory when the user is created, which is a scenario called insert. We can then set a min and max length for the two fields, and then we can check that the two versions of the password are the same using the compare function. Now we need to reflect this in the database, so we can use a before save event. If it's a new record, then save the password, and also set the create date. Otherwise, has the password changed, and are both fields the same value, and if so, save. Then we can add these two fields to the attribute labels. There, that's all done. So users can change and save their details. Now let's just check the Ajax validation on the password works as well. So that shows I typed in different values, and now I'll type in the same values and save. and that all works as well. Great, so now we've seen how to extend the web user class to store application-specific information, and also updated the user form to enable password comparison and update functionality. In our next session, we'll look at how user security is applied to the controller actions. Hello. In our last few sessions, we've looked at user authentication and extending the web user class. Now we need to follow this security through to the controller, validating that the user is authorized to execute the requested action on the requested data. In our application, we've split our controller actions into two tiers. The first tier, which is publicly available and can therefore be run by anyone, includes the index and view actions. In our album model, this enables anybody, guest or logged-in user, to run these actions, and thus these actions make up the functionality of the front end of our website. The second tier, which is only available to logged-in users, enables those users to list, update, create and delete albums, and to upload photos to those albums. Many applications will have a third tier for administrative users, where functions like delete or creating new users would be available. These tiers and which actions are available to each are implemented within each controller using access rules. In the generated code, we can see that Yii has split the actions into those three tiers we just discussed. All users, indicated by using a star, can run the index and view actions. Logged-in users, indicated by using an @ symbol, can run the create and update actions. And an admin user can run admin and delete actions. You'll often see, particularly in Yii generated code, users get array admin. But don't be fooled by this. This means a user called admin. And remember that usernames are unique, so this is not particularly useful. But you can refer to a list of comma-separated usernames if you wish. And lastly, a catch anything else safety net. All users are denied any other actions that we haven't defined above. In our album controller, we've already added the photo upload action to logged-in users, and now we'll also allow logged-in users to run the admin and delete functions. Other available access rule options are expression, like Yii @user_is_admin, IPs, which is a list of IP addresses, roles is a list of roles if you're using Yii RBAC functionality, and verbs could be get or post. Now these access rules are really a type of predefined filter, and we can see the filters method is already defined and runs the access control function, which is defined in the C controller base class. Also defined here is a post-only function, which is defined to run only on the delete action. The plus sign means run only this list of actions, whereas a minus sign would mean all actions except those in this list. Now back to the admin action, which lists those albums belonging to the current user. The user can click delete or update, but we haven't actually checked anywhere in these actions that the user really does own this album before allowing the user to complete the update or delete action. So far, we've assumed that because the admin action only lists the albums belonging to the current user, that other albums aren't accessible. But if we tamper with the URL, we could access an album belonging to somebody else. Before running these actions, we could check that the user actually is the owner of this record. And we could put this functionality into each controller action. Or better still, we could define a filter to do this across multiple actions in this controller. So let's create a filter and we'll call it checkOwner. And the parameter is a filter chain, and we use this to call the next filter in the chain at the end of this filter. First we need to check that the ID of the album has been passed in the URL. And then we load the model for that ID. And if the model owner is the same as the current owner, we can continue the filter chain. Otherwise, we'll output an invalid error message. Now we need to add our new filter to the filter chain. First, we define the filter name, and then we only want this to run on update, upload, and delete. Okay, let's try that. So we browse the albums belonging to us. We can update them, but if we change the URL, our new filter stops us. So in this session, we've seen how to apply controller-level user security to our actions, and how we can use filters across actions. And in the next section, we'll be looking at debugging, logging, and error handling in Yii. Hello! In this session, we'll install and configure the Xdebug extension for PHP, and set up NetBeans to be able to debug our project directly. There are occasions when we need to step through our code line by line to find that elusive bug or to trace the value of a variable. And Xdebug is the tool for this job. If you haven't already got Xdebug installed, then you'll need to download the appropriate executable from the xdebug.org website. Or on a LAMP system, you could use apt-get install PHP 5-xdebug. Whichever system you're using, the installation wizard xdebug.org/wizard.php will help you configure your particular system, and all you need do is paste in the output from a PHP info statement, and the wizard will give you instructions tailored to your particular installation. So paste it in, click Analyze, and follow the instructions. I also needed to add the following lines to my PHPUnit file. I'm using a WAMP server, so I can click the WAMP icon, PHP and php.ini, and then it opens in my default editor, and these are the lines I added. And then in NetBeans, you don't really need to install anything or change any particular config details, though it's worth checking these two areas. Firstly, in the Tools option PHP Debugging tab, I've unclicked the Stop at First Line option, as I prefer the debugger just to run straight through to my breakpoint. And then the second area to check is if you right-click on your project, set Configuration, Customize, and then Sources, and make sure that your web route is set to www. Okay, so now we can run Xdebug right from the NetBeans toolbar. So we're going to check the before save event in the album model. I want to check how the album owner column is being set. So let's set a break in the album controller create action. And the first time through this action, the $post won't be set. So it will fall through here and just render the create view. So if we set the break on the $model attributes equals $_post line, and then it'll break the second time through after we've hit save. Before we run that though, I've done a small change to my album's admin view to add a new album button. And whilst I was there, I also changed the style of the existing advanced search button and got rid of the extra text that was being displayed at the top. Okay, now in NetBeans we can click the Debug Project button, and it should fire up the browser going to our default start page. I'm already logged in, so we can go directly to the My Albums page. And here you can see my new album button. And we click that. We're going to call this Modern Architecture, this album. And I'll just paste in some details into the description box and then click Save. And NetBeans will then hit our breakpoint on the $model attributes line. Now while we're here, let's just pause and have a quick look at the debugging tools. The toolbar provides the main controls for debugging, much like most other debuggers, and we can step through the code line by line. We can use the stop button to finish debugging, resume, step over the execution statement, step into, which means follow any code underneath that is used to execute that command, step out of, so if we're in a subfunction, we can execute to the end of it and step back to our main function, and then we can run to the cursor. Also, there are a number of NetBeans windows available through the Windows debugging menu. And the most important of these is the variables window, where we can inspect the variables at runtime. There's also a watch window which allows us to set breakpoints on variables, but NetBeans warns that this is unstable. You may also have noticed that if you hover over a variable which is in the current context, it'll show you the value of that variable. Now back to our debugging. So we can jump over the first line and then into the save, and again we can jump over the validation and then into the insert, and then over the next few lines, and then into the before save, and again, and then here we are in the album controller before save event. We can view the variables, Windows debugging variables, and we can see here the superglobals and the $this variable. We'll also add the user ID using Yii app user ID. And then we skip to that line, and we can see the user ID is set to 2. And then if we step over that line and check the value of our model owner by expanding $this_attributes, we can see that the owner ID has been set correctly. Great, so now we can debug our Yii projects in NetBeans. So in this session, we've seen how to install and configure Xdebug and use it to debug our application line by line. And in our next session, we'll be looking at another important tool for debugging and monitoring our application, Yii logging. Okay, in this session we're going to look at Yii logging and how we can configure the system to use different log files or routes for different levels and for different categories of messages. Sometimes we can be outputting so much information into a log file that it's either difficult to sort the wood from the trees or the log rotation is so quick that we can miss something. Using log routes will enable us to divert output to different files for different log levels and categories. When we configured our Yii application back in section 2.3, we configured the logging to be output using the standard C file log route. And if we check the runtime directory, we can see the standard application log file and previous versions of it in a log rotation format. Also, back in section 2.2, we updated the main bootstrap index.php file, and we added a function to dump messages into the log. In that function, we used a Yii function called log, like this. And this log function takes three parameters. The first, $what in this case, is the variable that we want to output to the log. Info is a logging level, and available levels are error, trace, warning, and info. Application.$where is called the category, and the category gives the output context, by which we mean where did that log message come from. An established format is to use the Yii path alias format in the form application.controller.action or application.model.method, and hence in our function we've defaulted the first application part. There is another logging method called trace, and the difference between the two is that trace messages are only output to the log when the system is in debug mode, whereas log messages are always output to the log. Also, trace doesn't take a level as the level is set to trace. By default, log messages are held in memory, and by specifying log routes, we can divert all or part of the log out as required. And each route is represented in Yii by a Yii base class, and the following log routes are available. CDB log route, which saves messages in a database table. C email log route sends messages to a specified email address. C file log route saves messages in a file under the application runtime directory. C web log route, which displays messages at the end of the current web page. And then C profile log route displays profiling messages at the end of the current web page. Initially, we set the logging to use the C file log route and the C web log route using the following configuration. Our dump to log function that we added to our bootstrap index.php file back in section 2.2 uses the info level. So from the above configuration, we would expect any output to be only on the bottom of the current web page and not to the log file. So let's add a message to our code. And we'll go to site index action, and we'll use our dump to log function, and we'll just output a test message, and the context will be site.index. Now if we go there in our browser, we'll see this in our web browser and not in the application.log. On a busy server, it may be difficult to find output that you need due to the volume of the logging output, or it may even get pushed off the bottom of the log rotation too quickly. For this, we could use a separate log file to trace or dump information for a particular area of the system as follows. So we're going to create another C file log route, and we'll create it just for the info level. We're going to specify the log file name and call it application_site.log. And then we're going to include in there the categories application.site.star. And then for our previous C file log route, we're going to add a categories and say where it's not equal to application.site.star. Categories can either be a string or an array. So now all the messages using a category of application.site.something will be output to our new log file and won't be output to the standard application log file. So let's try that. We refresh the site index page. We'll reload our application.log file and we'll see that the message has not been added there. And then we'll load our new application_site.log and we see the message there. So in this session, we've seen how to configure the Yii logging system and use different log routes, levels, and categories. And in our next session, we'll look at profiling and logging SQL queries. Hello! In our last session we looked at log routes, levels and categories. And in this session we're going to look at debugging SQL queries, profiling both SQL queries and execution times, and logging SQL parameters. As our applications grow in complexity, both in logic and in data terms, it becomes more and more important to be able to target bottlenecks in the application, and SQL debugging and profiling will enable us to more accurately analyze and pinpoint those bottlenecks and produce more efficient SQL and code. There are two areas in the system config file that affect the way that SQL queries are logged. Firstly, in the DB component, there are two parameters available. Enable parameter logging, which when set to true will log the parameters that are bound to SQL queries, and enable profiling, which set to true if you'd like to see SQL runtime timings. And we've already got those set in our main.php. On their own, these two parameters won't make any difference to the log output. We'll also need to change something in the log routes to include SQL logging. For this session, we'll use the C weblog route, as this is the quickest and easiest to see, but we could equally use any of the other log routes with the same parameters. So we need to add an entry to our C weblog route to display SQL logging. And first we'll add the trace level. And this will display a trace of the call stack, including SQL commands. It displays the SQL and the SQL parameters, but as you can see, it doesn't display any runtime metrics. We could add a category to this trace, and we'll specify system.db.star. And now this will only display trace information for SQL queries, as you can see here. Now looking at the actual output, the first thing that we'll notice is that the album photos relation is being lazy loaded, and that is, for each album record, the system then goes and gets the photo record with a separate query. And that's okay for low volumes, but with a very simple addition to our SQL query, we could get the system to join the two tables, resulting in only one query overall. So in our album controller, index action, we could add a with clause to our Yii ActiveRecord to include the photos relation from the album model. And now if we rerun that, we'll see that multiple queries for each photo have been combined into just one joined SQL. So back to our config file, if we change the trace level to profile, we get start and end times for each query. We can also profile chunks of code by adding begin profile and end profile statements around the chunk we want to profile. So if we go back to the album controller and add a begin profile here and then an end profile after the render, and the parameter here is profile ID, and it's just a string that identifies this chunk of code. And before we run, we'll need to comment out the categories on our C weblog route. And then we should get the start and end times for that piece of code here and here. Another useful log route is a C profile log route, and this will display summary information for the profiled log route, and the report type can either be summary or call stack. And here we can see a summary for each of the SQL commands with the total time taken, the average, and so on. One last useful parameter is the show in Firebug parameter, which will pass the C weblog route output to the browser console, rather than displaying it at the bottom of the web page. And open the console window, and we can see there. And notice that it also works in Chrome. So in this session, we've seen different ways to profile and log SQL queries. And we've also seen an instance of lazy loading that we changed to eager loading using a with clause on the C ActiveRecord. And in our next session, we'll look at using a Yii debug extension toolbar. Hello, in this session, we're going to install and discover the Yii debug toolbar extension. This is a fantastic tool that gives a huge amount of information about the running page, with insights into page requests, views being rendered, SQL traces and metrics, and Yii logging. You'll very quickly find it indispensable in your development process. We've installed a few extensions already, and the procedure for this extension is much the same. We download the zip file from the Yii extensions website, and then we open the zip file and copy the directory into the protected extensions folder. And then to configure the extension, we add a new log route to config main.php. and then you need to check the IP addresses match your own IP address. Another extension worth mentioning, if you're a Google Chrome user, is the PHP console extension. And again, we can download the zip file for this, open it, and copy to our extensions directory. And again, this needs another log root in our config file, so we can add this to our config file as well. To get this extension to work, you'll also need to install the PHP console Chrome extension. Now let's go and see how they work, starting with the debug toolbar. If we refresh our home page, and we'll see the Yii debug toolbar on the right. You can hide the toolbar by clicking this little blue bug and then back on. Now the server tab gives a PHP info style output and much more. And then the request tab gives page request information, and I find this particularly useful for checking post requests. Here's a fairly complex page from an application that I developed a while ago, and if I save that page, notice the flash message here, but then we can go in and check the post information, and we'll see that there are two arrays of post information down here. Back to the debug toolbar, Settings tab shows a lot of useful information, some of which comes from the config file, but for me the most useful here is the client script output. When you start using Ajax widgets, like the grid view, you'll find that Yii embeds snippets of JavaScript, and rather than scrolling through source code in the browser, and it can be quite difficult to find at times, you can very quickly check what JavaScript is included here. And obviously, if you want to debug the JavaScript, you'll still need to use the browser debugger. Views Rendering tab shows an entry for each view that has been rendered, including the layouts and the main layout view. And you can drill down to see what variables have been passed through to each view. The SQL tab is much like the log outputs that we saw in our last session, but in a much more readable format. This tab displays each piece of SQL that was executed for that page and gives real insight into SQL bottlenecks and also unnecessary lazy loadings. The logging tab, like the SQL tab, but it's a much tidier rendition of the C weblog route, and also it makes the lazy loadings very obvious. As the debug toolbar outputs all the logging information that in our last session we added to the C weblog route, we could remove the C weblog route, which will keep our page tidier, particularly when rendering subpages in pop-ups. So we'll remove that from the config file, refresh, and we don't have the C weblog route, but we still have all the information in our toolbar. So now to the PHP console extension. Using this extension, we can dump variables into the Chrome console without messing up our page output with var dumps. A while ago, we used the site index view to dump some user information. So let's update that to output to the PHP console instead. We'll use a debug function provided by the console extension, and then we'll reference a variable that doesn't exist, and lastly throw an exception. And then we'll run that, and we can see the warning messages with pop-ups too, and the output of the variables. So now that we're all tooled up to debug our applications, in our next session we'll be adding error handling to our application and see how Yii handles error pages. Hello! In this session we're going to review the Yii error handling implementation and how to extend it to suit most web applications. It's important to use error handling in all kinds of applications, not just to give the user a better experience, but also from a security perspective, to hide the specifics of that error condition from any would-be hackers probing the system. And Yii makes it very easy to do this. Yii integrates the PHP 5 error and exception mechanism into its framework by calling the setErrorHandler and the setExceptionHandler in application startup. Here, Yii registers the methods handleError for warnings and errors, and handleException to manage uncaught PHP exceptions. These are both part of the setErrorHandler class. Exceptions are raised using the syntax throw_new_exception class with exception message, where the exception class is one of the following. C exception for generic all-purpose exceptions, CHTTP exception for exceptions that should be displayed to end users, such as mistyped URLs, and the CDB exception, which is used for exceptions caused by a database-related error, such as SQL syntax and so on. Back in section 6.5, we added a check owner filter to our album model, where we check that the album being requested by any maintenance operation is actually owned by the current user, and if not, we just displayed an error, invalid request. So we should go back here and change this to a proper exception statement. So we'll use throw new CHTTP exception and then set it to a 404 error message and say the requested album is not available. Okay, let's check that. So we go to our albums and we choose one of ours, and then we just go and fiddle with the URL to try and access someone else's. And yes, we get a 404. So that's working. Yii has an inbuilt system to decide which error views are used in which error circumstances. But as this mechanism circumvents the layout display mechanism, it doesn't follow your theme or site layouts at all, and thus I find them of limited use. And instead, we could use an error action, and this has already been defined in our main configuration file using the error handling component with the definition as follows. And this overrides all those previous mechanisms. Thus, we can tailor the site error action to handle the errors as required. So in our site controller, looking at the error action, firstly we can see that it checks that the error handler has an error, and if so, returns an array with error details. And then next it distinguishes between an error in an AJAX context or a standard context. And within the standard context, it renders the error view. So we could update that view to display more detail when the system is in debug mode. So we'll edit the view site error.php and we'll add a table displaying all the error output. First we check that the system is in debug mode, and then we output the error variables. Okay, let's try that, and we'll navigate to an unknown URL. And as expected, we get all our debug error output. Now we go back to the site controller, and when it hits an AJAX error, it's just outputting an error message. And that would be really difficult to trap in our $getReturn, and I'm not sure how we would do it. So instead, we need to output a decent JSON response. And then in our JavaScript, we can catch the error return and handle the error decently. So under the isAjax request, we'll output a JSON response. And we set the response header to JSON first, and then we use a class called CJavaScript to output the JSON for us. And we'll set the result to 0 or false, and then we'll output the error array. Now I've already built a little AJAX view to test this, and you can copy it in from section 7 download. It's well commented, so you can follow the code in there. And then we'll change the index action to call this new view. Okay, now let's go back and try that. So we'll call the site index, and we get our button, and we'll click the button, and yes, we get an error. Brilliant. So now we have a complete error handling system, and we've seen how to differentiate between debug mode and production mode, and how to handle AJAX requests and standard requests. Hello! In this section, Section 8, we'll continue to develop the album interface, and in particular by adding support for tagging and comments. And in this session, we're going to be building the tagging functionality on both albums and photos. And we'll see how to use cross-model functionality that demonstrates how an MVC architecture holds the business rules at the model level, and in this case, the tags. We've a lot to cover in this session, and we're going to start by copying much of the core functionality from the blog demo that comes with the Yii framework. So here's a checklist of the steps that we'll be taking. So first we copy the tag model from the blog demo, and I'll move the old model out of the way, and then go to the blog demo, copy the tag model and paste it into our application. And then we need to edit the tag model and change the table name to table tag. Next, we need to copy elements of the post model from the blog demo. So we'll copy the code from the getTags function all the way down, but excluding find recent posts. And then we paste that into our album model. We delete the before save block, as we already have one of those. And then in the tag links, we change the URL to album search, and then add some HTML options on the end to format the button. And then in the after delete, we change post to album, and then we don't need the add comment method. And then we need to add the class variable old tags, and then we need to repeat that procedure for the photo model. Now we'll need to let users search for these tags. So I've already added a search text box to the PhotoGal main layout, and it's embedded in a form that has an action of album search. So we need to create a new search action in our album controller. So in our album controller, we create a new search action, and the form uses get rather than post, as it'll also be used on tag links. So we check for the tag request parameter and then assign it to a variable. For simplicity and reuse, I'm going to display the results using the index view, and this uses a C active data provider, so we need to use one here as well. And this is very similar to the model search, so we can crib the code from here. So we create a new criteria object. And then the tag condition will need to use the query string of %tagname%. So we can't use a compare, we'll need to use an add search condition. And then we limit the search to use our shareable scope. And then we can build the data provider and then render the form. I'm also going to pass the tag name through to the form so that we can use it in a heading. We also need to copy an action called suggest tags from the post controller and paste that into the album and the photo controller. So we'll just paste that in here for now. And then don't forget to add these to the rules. The search is available to anyone, and the suggest tags is only used in the admin, so used for logged in users. So our data models and controllers are now ready. And next we'll need to change album update and index views, and we'll do this in the next session. Hello! Continuing from our last session where we copied some functionality from the Yii blog demo and also readied our application to be able to search on tags. In this session we'll continue with adding tagging functionality to our album views. The tags functionality stores the tags in a single text field using a comma delimited approach. So we need to present this to users in an understandable and easy to use manner. So to this end we'll be adding an autocomplete widget to the album update form. So first we need to change the album update form. And here we're going to use an autocomplete widget to help with tag completion. So in the views album_form, we'll replace the tag text field here with an autocomplete widget. The model is our $model, and the attributes is tags. And then the URL, this is where we're going to use the suggest tags action that we've just added to the album and photo controllers. And then we set multiple to true. And then we add some HTML options that we need. And then we need to display the tags on the album index. And the album index uses a list view using the underscore view. So in there, views album underscore view, we'll add another div and then display the tags using the tag links method we just added to the album model. Then going back to the index view, we'll change the heading to include the tag being searched. But we need to allow the index action which doesn't pass the tags variable. So we check if the $tag is set, and if it is, then we display a heading with the $tag, and if it isn't, we display the original heading. Okay, so that should all work now, so let's go and have a look. If we go to the home page, remember that's album index, that works, but let's change one of our albums to have some tags. So we go to our albums, choose one, put some tags in, and then save. And then if we go back to the home page, and we'll see the tags being displayed, we can click on them to search directly, and we can use the search box. And then if we go back to one of our albums, and we'll choose another one, and then enter a tag we just entered into the other album, we'll see the autocomplete working. Great, that's all working now. In our photo model, we have a created and an update date, and the created date is set within the database using a default value equals current timestamp. But we haven't yet created anything to maintain the updated date. We've already seen model events, and we could use a before save. But Yii also has things called behaviors that enable us to link application-wide methods to an object. So this would be particularly useful where you want to add the same function to multiple models. And yes, you got it, like updating an update date. Or it could be deleting a record, or logging transactions, and so on. So in our photo model, we can create a behavior method, and it returns an array. And then we can use a Yii component called cTimestamp behavior. And this will maintain both the create and update dates. And in our case here, we're just going to use the update date. And that's it. That will maintain the date for us. Okay, so in the last two sessions, we've copied some of the tagging functionality from the Yii blog demo. And it's demonstrated how we can hold the tagging business rules within the tag model. We've also added a new search action using a data provider object. And we've met Yii behaviors. And in our next session, we'll look at using lookups and drop-down list boxes. Hello. In this session, we're going to add a drop-down box to our album admin form, which in turn will require a new relationship and a new custom validation rule. We'll see how we can easily integrate cross-table lookups using relationships and the list data method. Our albums have a category column, which until now we pretty much glossed over. We have a table called option, which is used to store system options and lookups. And we're going to add an album category to this table, which will be linked to a drop-down box on the album. This column will describe the type of photography within this album, for example, black and white or fashion, still life, landscape, etc. So firstly, we'll define a relationship in the album model for our category ID, which is just that little bit more tricky than normal. The SQL join would look something like this, where the inner join is on both the ID, the category ID, and the table option name is equal to category. So this would give us a relation like this, where the relationship belongs to the options table, using the category ID as the foreign key. So it would assume the primary key of the option table is ID. And then we have an added additional on clause using option name equals category. So we'll be able to reference the category name from the options table from our album model using $album categories option name. Next, we can look at validating the category ID. As this is a user input field, we should validate it using a whitelist approach. And so the best way would be to check that it's a valid category ID against the option table. So we'll build a function and call it checkCategory. And this function will select from the option table using the category ID. First, we'll check whether the category ID is blank, and this is OK, so we can return true. And then we'll build a command object, as this is more efficient than using model objects. And we check the option name equals category, and the ID equals category ID. But we'll bind the category ID using PDO, as this is safer than embedding it directly in the SQL. And then we'll check that something was returned, and that's OK. Otherwise, we generate an error by adding an error to the validation error object. Now we can add this function to our validation, and the column is category ID, and the validation name is the name of our function. To test that before putting in a drop-down box, we need to add back the category ID text field that we deleted way back in section 3. And then we'll need to check the following bounds of the category ID. Category ID could be blank, or it could be an integer but not a valid category ID. It could be valid, and then it could also be a non-integer value. Okay, now we can add the drop-down box in our views album _ form, and we replace the text field with an active drop-down list. Active means that it's bound to a model object, so the model is $model, the name is category ID, and then the list data, we can use a method called listData, and it takes as parameters a list of model objects. So we look at the option model, find all, and then specify the where condition. Alternatively, we could use a CDB command object like we just did in our checkCategory function, and this returns an array of associative arrays. And then the next options are the select and data column names. And then we can specify HTML options. Okay, let's go and try that. We go to our albums, select an album, and we have a drop-down list. We choose one and save. Great. Now we just need to add that to our home page. So we go to views album _ view, and we'll add it just here inside a paragraph. And first check that there is a category to display, and then we'll display it using CHTML encode to encode the field. Okay, so I've just been through and added some more categories to our album, so let's go and look at the home page now. Great, that's all working very nicely. So in this session, we've added a relation using an additional on statement. We built a custom validation routine and added a drop-down list box. In our next session, we'll be looking at using behaviors in data models. Hello! Our photo application is nearing completion now, and in this session we'll add the ability to add comments to photos for logged-in users. When we start mixing models up in our processes, it sometimes becomes unclear about where one should add functionality and how to keep the split of, for example, views between cross-model references. By that I mean, should we add comment forms into the photo model or keep them distinct within the comment model? Here we'll see both adding an add comment function to the photo model, but keeping the forms separate. So in our photo model, we'll use a method to add a comment and set all the default values. So we create our add comment function, and it takes a comment model as a parameter. And at this stage, we're not going to implement the approval of comments, so here we'll default the status to approved. And then we bind it to this photo and set the author to the current user, and save and return the comment model. While we're here in the photo model, we'll make a small change to the comments relation to order the comments by create date. Next will be the comment input form. So we go to views comment _ form. And here we can remove everything except for the content. And then the _ view to display the comment. And here we're going to completely change the layout. So I'll insert a new layout that I've already created, and then we can move the fields in. Firstly, the content, and then the author ID label, and then the author's full name, the date created label, and the date created itself. And then we can delete everything else. Okay. Next, in our photo view, so we go to Views, Photo, View. First, I'm just going to update the breadcrumbs, and then we'll remove these submenus. And then I'm going to use a subform to display the photo details. And so let's create that straight away. We'll call that _photo. And it's very simple, it's just a few divs. And then we display the image using CHTML image, then the image URL which we get from the model, and then we display the alt text. And then the caption. Okay, we'll save that, and then let's go back to the view form. And then we're going to use our two comment forms that we've just updated. So firstly, to display a list of comments by looping through each comment for this photo and rendering the _ view. And then for logged in users, not is guest, we render the _ form view. Otherwise we display a message. Okay, now we need an action to process that somewhere. We're displaying a photo, so that would be the photo controller and the view action. And we need to remember that when the comment form is submitted, it'll come through the same action. So we need to build two paths within this action, as we've already seen in previous update actions. So first we need to create a new comment model, and then we check for a $post. And if it's there, we assign the comment attributes, which in fact will just be the comment content. And then we use our photo add comment method to add the comment, and if successful, we'll need to refresh the page as we've added a comment to the photo, so we'll need to reinitialize the photo object. And then we pass a comment through to the views. Now we need to get here from somewhere, and that somewhere will be from the album view, and we'll change the comment count just underneath each photo to be a link to the photo view that we've just updated. So that's in Views Album View, which then partially renders the Views Photo index, which in turn renders the Views Photo _ view. So that's where we're going. And we'll change this to a link to the Photo View view. And then just a cosmetic change, rather than display a 0, I'm going to change that to a plus. Okay, that should be about it now, so let's go and have a try. So we go to our home page, and then we'll go into the Beaches album, and we have a plus because we don't have any comments there. So we'll choose a photo, and we'll go into the view form for the photo, and we've got our comment form underneath. We'll add a comment, click create, and it goes back to the view form, and there we are. We've got a comment listed. So let's add another comment, and click create. And there we've got 2 comments. That's brilliant, that's all working. So now our application is ready to push into production. In our next session, we'll look at what we need to do to ready our code for deployment. We've completed the first phase of the development of our photo application, and now it's ready to deploy either into production or testing environment. But before we push it across, there are a number of things that we need to do first. In smaller application development teams, it's easy to keep track of development versus production configurations. But even then, it's important to be aware of overwriting the production configuration. In larger systems, it becomes imperative to split the configuration file into manageable portions. In this session, we'll see how to do this and also set other production server settings. As much of our original code was auto-generated by Yii, there are bound to be areas that were created but we don't actually need. And now would be a good time to prune out these unneeded surplus bits of code, both from a housekeeping perspective and also for security, in that these areas may not have the correct business rules assigned or may give access to areas that we don't want. So here's a list of what we can remove from the application. So let's just nip through and delete all those. So that's removed a lot of dead wood. And next we can look at our main configuration. That's the protected config main.php file. Firstly, and one of the most important things, is we must remove access to Yii. Can you imagine if somebody managed to get access to a production server through Yii? How embarrassing would that be? In the database, we can set the enable parameter logging and enable profiling to false to remove any chance of debugging information. We can also configure schema caching duration, which will cache the schema lookups that you may have noticed when we were debugging our application. Each time that Yii creates a data model, it'll interrogate the schema from the database. So we can potentially save a lot of database traffic by enabling this. So we'll set the schema caching to 120 seconds. However, this won't have any effect on its own. We also need to define some form of database caching. And the simplest form is file caching. So separately, we define the cache component and set the class to a file cache. Obviously, our database access parameters will be different on our testing and production servers. So we would need to change these as well. But rather than changing them here directly, what we can do is create a separate configuration file. So we'll remove the database config parameters from here, and instead we'll import a separate dbconfig file. Using require, set the directory name, and then we'll call it db_config.php. We'll then create this file, and we can paste our database parameters in here. Now what I often do is in here I'll put a condition to check which server we're running on. So I'll specify the server name of my development environment and set the database parameters for that. And then in the else assume that I'm in my production environment and set different parameters there. Going back to our main config, the logging, we should remove all but the cfile log route and then probably just output the errors and warnings. Depending on how busy your production server is, you may want to split your file output into separate files. But here we're going to leave both errors and warnings going to the same file. That's about it for the config file. We're currently running the application in debug mode. And this is set in our bootstrap index.php file. So if we open that, and we set Yii debug to false. So that's it, we're ready to go. I'd like to thank you for following me on this journey through Yii, and I hope you've enjoyed it as much as I have. In the last 8 sessions, we've covered a lot from the basics of the MVC architecture, installing and setting up Yii, and then the development of our first photo gallery application, testing, theming, and user security as well. I'm already planning many more enhancements and look forward to meeting you again soon to discuss and further this application. If you have any suggestions, then I very much look forward to hearing from you, either via the PAC website or directly via my website. Thank you again, and happy Yii development.